Hello everyone, my name is Koma Signolo. Welcome to another video by Attention Matrix, where we try to make learning fun and easy. Please comment, like, and subscribe if you would like us to continue making this content and you enjoy it or find it helpful. Now on to the next video. Let's get right into it. Okay, for this lesson, we will continue with series. Okay, so I just want to explain the sigma notation in this lesson. We've been dealing so far with arithmetic series and sequences, and for this specific lesson, I just want to deal with the sigma notation. Okay, so sigma notation, because that will help us a lot in addressing some problems regarding series. Okay, it's just a way of expressing our series. Sigma notation is essentially just a way of expressing a series. Okay, so what is sigma notation? Let me just zoom out a bit. Well, sigma notation is as follows. I'm sure you have seen this sign before. Now, this sign simply means the sum of. Okay, it just means the sum of. It means that whatever comes after the sign, you're supposed to find the sum of that thing. Okay, so I'm gonna go through a couple of examples just to make this make sense. Now, remember what a series is. A series is simply, if you have a sequence, say 1, 2, 3. This is actually supposed to be semicolons, so let me just make it semicolons. Semicolon 1, 2, 3, 4, 5, 6, etc., etc. All right. This is a sequence. Now, what a series is just an addition of the terms in the sequence. So it's going to be, this is a series: 1 plus 2 plus 3 plus 4 plus 5, etc., etc., etc. Now, sigma notation simply helps us express this series in a compressed form, or in short form, right? So instead of writing this entire thing out, we can write it in sigma notation. Now, how would you write that in sigma notation? Remember the sign, that sign there that looks like an E with a curved middle body, simply means the sum of, right? So if I have, for instance, sigma, and then I have, say, let's use the letter P. Okay, it's just a random letter P, and then at the bottom there I have P is equal to 1, and then I have 5 there at the top. What this means is that I've got a formula. My formula is P, right? I know it's just a single letter, but say I've got a formula. My formula is P, right? That's all that it is. My formula is P, and I want to substitute different terms in my formula starting from 1, ending at 5, and then adding all those terms up. So since my formula is P, this is what I'm going to be substituting those numbers for. Which numbers? 1 to 5. So I start from 1 and I stop at 5. So how do we do that? Well, I simply say, okay, so P is my formula. Remember, P is my formula. Now, if I had to write a sequence for this thing, you don't have to do this when you're solving. I'm just doing it for purposes of explanation. Okay, so if you had to have a sequence from this, you would know that if P is your formula, then T1 would be P when P is equal to 1. Okay, because 1 is the first number that you start off with. Term 2 would be P when P is equal to the number after 1, which is 2, right? Term 3 would be P when P is equal to 3. Term 4 would be P when p is equal to 4. And then term 5 would be p when p is equal to 5. Now, what this sigma notation means here, remember, I'm going to keep repeating myself so that I make sure that this is understood, well understood. Sigma, okay, that sign for sigma, this sign simply means that you add whatever comes in front of it after substituting all the relevant terms. Okay, starting with the number at the bottom, ending with the number at the top. Okay, so we got all the different terms. We got all the different terms, starting with the number at the bottom, which was 1, ending with the number on top, which is 5. Now that we've got all the terms, we can simply add them up. That's all that it means. Remember, I'm saying it's a compressed version of what a series is. You're just representing a series in its compressed form. So, just going to do that. So, in other words, sigma of p starting from p is equal to 1, ending at p is equal to 5 is equal to term 1 plus term 2 plus term 3 plus term 4 plus term 5. Why do I stop at 5? Because the number on top is 5. Why do I start at 1? Because the number at the bottom is 1. Okay, and then I just add all of them. Now that's going to be T1 is 1, plus T2 is 2, T3 is 3, T4 is 4, and T5 is 5. Okay, and then adding all those up, what you are going to get is 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, so you are going to get 15. Okay, when you add all of these up, you get 15, and that's all that it means. Okay, I want to do a couple of more examples, 1 or 2 more examples, just to illustrate the point further. Let's say I've got sigma, and then from I is equal to, is equal to 3, stopping at 4. Okay, stopping at 4, and the equation here is I, or the formula is I plus, let's say I, this thing keeps disappearing, I don't know why, I plus 2. What does this tell you? Well, first thing you need to look at is the formula. You look at the formula. There's your formula. It's been given there. Your formula is I plus 2. Your formula is I plus 2. Okay, so you need to find all the terms from this formula of I plus 2. You need to find all the terms. Okay, so you need to find all the terms where you substitute I is equal to 3 to get the first term, and you substitute I is equal to 4 to get the last term. Okay, so term 1 is going to be I plus 2, which is your formula, but I will have to be 3. Okay, I will have to be 3, meaning that this is going to be 3 plus 2, and that's going to give you 5. Okay, so that's your first term, right? What's your second term? Well, you do the same thing. T2, term number 2, your formula is I plus 2. Okay, your formula is I plus 2, but for your term number 2, it's the term that follows 3. Remember, let me go back to the sigma notation thing. The first term is 3, meaning that the next term, or the next value that you're going to substitute in place of I is the number after 3, which is 4. It's the integer after 3, which is 4. This is the first number, and then the next number is going to be the next integer. So the next integer is 4, right? but then 4 happens to also be the last number that you can substitute. So it means that you're going to stop at 4 because 4 is the last number there on top. So if we go back down here, I say term number 2 is I plus 2, where I is equal to 4, right? You started with 3, now I is 4, and then meaning that this is going to be 4 plus 2, meaning that this is going to be 6. Okay, so that's 6, and then that's 5. So the first term, so in other words, if I'm going to express this the way I expressed it initially, this is sigma, and then this is 4 on top. I is equal to 3. Okay, and I've got I plus 2 there. I've got I plus 2. So this is equal to T1 plus T2, right? T1 and T2, where T1 is when I is equal to 3, and T2 is when I is equal to 4. I is equal to 3, then I is equal to 4, is equal to 4. Okay, so T1 plus T2. What's T1 and T2? Well, T1 we discovered is on top there. T1 is here. T1 is 5, right? T1 is 5 and T2 is 6. So 5 plus 6, that's our answer. 5 plus 6. 5 plus 6 is equal to 11. Therefore, the answer to this thing here is 11. Okay, let's do another one. Another example. Let's say you've got sigma from n is equal to 0, and then up here that's 6, and then here let's say you've got n squared plus 1, whatever. Okay, what is the answer for this thing, and what does it mean? Remember, the first thing to do is you look at the formula that's been given in front of the sigma. There's n squared plus 1. There's your formula, n squared plus 1. There's your formula. And we know which value of n do we substitute into this formula. Which value of n do we substitute into this formula? Which value of n do we start off with? Okay, so the value of n that we start off with is 0, because 0 is the value on the bottom there. And then we end with 6, which is the value on the top there. Okay, we end with 6 because the 6 is that value at the top. It's that value there, that's 6. Okay, so for term number 1, we know that our formula, n squared plus 1, we know that n has to be 0 because 0 is the number at the bottom there. So it's going to be 0 squared plus 1, which is equal to 1. Okay, so the term number 1 is 1. Now, which value of n should we use now for term 2? The value, the next integer after 0 is 1. Okay, so we start off with 0, and then the next number we're going to use is 1. Then after 1, you're going to use 2. After 2, you're going to use 3. After 3, you're going to use 4. After 4, you're going to use 5. After 5, you're going to use 6. And then we're going to stop at 6. Why do we stop at 6? Because the number on top is 6. Because that number on top of the sigma is 6. Okay, so let's do that. So what is our term number 2? Well, term number 2 is when n is equal to 1. Okay, term number 2, n squared plus 1, it's when n is equal to 1, right? 1 squared plus 1, and that's going to give us 1 plus 1, and that's going to give us 2. Okay, and then for term 3 is going to be when n squared plus 1, when n is equal to, we used 1 here on top, so now we're going to use 2, right? 2 squared plus 1, this is going to give us 4 plus 1, and the answer then is going to be 5. Okay, so for term number 4, we keep doing this up until we use n is equal to 6, because at the top there, n is equal to 6. Okay, so we are going to say term number 4 is equal to n squared, which is our formula in front of the sigma. Then the value in place of n is 3, then squared plus 1. That's 3 squared is 9, okay, plus 1. So 9 plus 1 is 10. Okay, and then for T5, we're going to have in place of n, for the formula of n squared plus 1, in place of n, we are going to have 4, right? 4 squared plus 1. 4 squared is 16 plus 1. That's going to give us 17. Okay, then we go to T6. This one is a bit of a long one. We go to T6. T6 is term number 6 is equal, in place of n, we are going to substitute. The last value we used for n was 4, right? So now we're going to use 5 squared plus 1, and that's going to give us 25, because 5 squared is 25, plus 1, and this is going to give us 26, right? We don't stop at this 6 here, not at this 6. N has to be 6. So n is 5 currently, right? N is 5. This is just terms, it means term 6. It doesn't mean that n is 6. Okay, this is not the same as what we did for arithmetic sequences. Do not confuse the two. Watch that first video lesson about series and sequences, and then rewatch this one and then notice the difference. Okay, and then the next one that we are going to move towards is T7 for which formula? The formula of n squared plus 1. Okay, where n in this case, the last n we used was 5, right? So in this case, we are going to use 6. 6 squared plus 1. And 6 squared is 36 plus 1. Now that's going to give us 37. And then we stop here. We stop here. Now, after we stop here, we add all the terms from term 1 to term 7. Why do we stop at term 7? Because at term 7, that's where n is equal to 6. Why is it important that we stop at n is equal to 6? Well, because the value at the top there is 6. We started with n is equal to 0. Okay, we started with n is equal to 0. We stop with n is equal to 6. We stop with n is equal to 6. Okay, so now we just add them all up, and we get to actually answer the question. So the sigma of n squared plus 1, where n is equal to 0 and stops at 6, is equal to T1 plus T2 plus T3 plus T4 plus T5 plus T6 plus T7. Okay, we stop at T7, remember, because that's where n was equal to 6. Now we just have to add all these different terms. We just have, let me just zoom out so that I can see all of them. Okay, and then what you have here is, you will notice that you've got all these terms here. Term 1 is, where's term 1? Term 1 is 1. Term 2 is 2. Term 3 is 5. Term 4 is 10. Term 5 is 17. Term 6 is 26. Term 7 is 37. So you just add up all those terms. You add up all these terms here, right? You add them all up. Okay, so let's do that. So what is 1 plus 2? 1 plus 2 is 3. What is 3 plus 5? 3 plus 5 is 8. What is 8 plus 10? 8 plus 10 is 18. What is 18 plus 17? 18 plus 17 is 35. What is 35 plus 26? 35 plus 26 is 35 plus 26 is 11 plus 50, which is 61. And then what is 61 plus 37? 61 plus 37, 61 plus 37 is 98. Okay, I hope I didn't make a mistake anywhere there. So 98. When you add all of these up, you should get the right answer. Hopefully I didn't make a mistake. Just double check this answer, make sure that I didn't make an arithmetic mistake. Actually, let me just check it now myself before.
No one cared when mom cheated on you.
Avoid making mistakes. Let's see. So that's gonna be 1 plus 2 plus 5 plus 10 plus 17 plus 26 plus 37. It's 98. Okay, yeah, so 98 is the correct answer. So that's simply what you would get. Okay, so that's the answer that you would get, 98. Okay, so that's basically sigma notation. Sigma notation, just it shouldn't be complete. It shouldn't matter what they put in front of the sigma. Okay, it shouldn't matter. It means the same thing. Here's the sigma. The number at the bottom is the number that you start off with. Doesn't matter the letter. Don't let the letter confuse you. K is equal to 7. They end here at 11, whatever. Even if they put something fancy here like k squared minus k plus k cubed over 2 minus k to the power 4. You follow the exact same procedure, the exact same thing. Okay, you start with k is equal to 7. Then wherever you see k, you put in 7. You put in 7, right? 7. You put in 7 wherever you see k. Then once you get the answer, you move on to k is equal to 8. Then wherever you see, now you don't put in 7, you put in 8. You don't put in 7, you put in 8. You get the next term. You don't put in 7, you put in 8. After you're done with 8, now you move on to k is equal to 9, up until you get to k is equal to 11, right? So you substitute for all the k's and then you add up all the answers, and then the answer that you get is your answer. This shouldn't confuse you. This shouldn't intimidate you. It shouldn't, it's the same. It's basically a compressed version of a series. Okay, it is a series. It's actually a series. Okay, just expressed in sigma notation. Okay, so that's it. You're gonna see this notation in sequences and series. They could use it with arithmetic. They could use it with the other different types of series and sequences that we are still going to cover. I think it's best to address it in the initial stages of this series, this lesson series, so that when we come across it in future, we don't get a shock. Okay, so that's all that this means. Till next time. Lesson number one, lesson number one. Lesson number one, lesson number one.